we've talked about atomic mass, and we've talked about mass number, right? This is the relative mass, okay? Your learning target, I will calculate the relative atomic mass of a particular element using the percent distribution of common isotopes. Okay, so the first thing you need to know is that the relative atomic mass accounts for all of the isotopes, right? So when we say that oxygen is 15.9999, it's because there's more than one isotope of oxygen, which means that there's differing amounts of mass for each of those atoms. Okay, so remember we call this oxygen 18. This oxygen has 18 in mass and 8 as the atomic number, or the number of protons. If you notice that the isotope mass and the relative atomic mass are not the same, they're not supposed to be. This is for this particular atom. This is the average of all the atoms of oxygen. Okay? So the relative atomic mass of an element is the average value for the isotopes of the element. Okay? So it's basically the average mass. Okay? It takes into account the percent the isotope is found on Earth. Okay? So for example, carbon has a couple different isotopes. The most common one is carbon 12. And that one is it's a little less than the 98 that they say here, because there's also carbon 14, which is a radioactive carbon, which was introduced right after World War II, after we bombed Japan. And so it's whatever the percentage amount that it actually exists as. So out of all the carbon, okay, carbon 12, 98.89% of it is carbon 12. That's what that means. Okay, to calculate the relative atomic mass, you multiply the percent abundance, that's this, times the isotope mass, right? So this is carbon 12. So I'm going to take 98.89%. Don't forget to put the percent sign in your calculator. And I multiply it by 12, which is the mass. Okay. I'm going to get that its relative mass is 11.8668. So we always want to go out like at least 4 digits. Okay. And then you repeat that step for each of the isotopes that you know, right? So we're also given that carbon 13 is 1.11%. So if I multiply 1.11% times 13, I get that mass is 0.1443. Okay. Once I've done all of my isotopes, then I'm just going to add all of the relative masses together. So once I've done all of the isotopes, then I'm going to add the numbers that I get here together. Okay. And that will end up being my relative mass. Now it should be somewhere close to the number that's on the periodic table. Okay, because the number on the periodic table, we call it the atomic mass, right? But really it's the relative mass. Okay, the relative atomic mass. Okay, so if I was to say, show me that the relative mass of chlorine is 35.45, okay, remember the first thing we do is we figure out what the percentages are of each of the of all of the isotopes. In this case, we're given that chlorine 35 has an abundance of 75%. Chlorine 37 has an abundance of 25%. Okay, so I'm going to take my chlorine 35, so my mass number is 35, and I'm going to multiply that by 75%. Okay, and so I get 26.25. I'm going to do the same thing with the chlorine 37, multiply that by 25%, and I get 9.25. If I add them together, I get 35.5. If you look at it, 35.45 and 35.5 is pretty close. Why aren't they exactly the same? Well, because there are other isotopes, right? So the 75% is probably more like 74 point something. And the 25% is probably like a 24 point something. And there are others that are in between that are much, much smaller. Okay. Then you would get exactly what it says. Okay. So this is relative atomic mass. Remember, the first thing that you do is find the percentages, right? They're usually going to be given to you. Then you're going to take the mass number, right? The isotope mass, multiply it by the abundance. Okay, that's this, to get the relative mass of that isotope. Once you have all of the isotopes done, then you're going to add the relative masses together to get your final atomic relative mass.